Hi, today we'll be looking at the 2015 PAT paper and going through question 15. Question 15 is a statics question. We're given some ball lying on a table with 3 strings pulling on the ball, each exerting a force on it. And we're asked to find the force on string C in terms of the force on string A, and to find a relationship between the force on string A and the force on string B. Now we're told that the ball does not move, which is hinted in the fact that it's a statics question. Now the fact that the ball does not move from rest means there cannot be a net force on this ball. So in any direction we consider the forces, they must all cancel off. There can be no resultant force or the object would accelerate by Newton's second law. So the way to approach these questions is to split it into vertical and horizontal directions and to resolve the forces in those two directions, to get 2 components for each force. And then you can compare forces in opposite directions to find one in terms of the other. So let's try that now. Let's start by considering forces in the horizontal direction. So we have a force A pulling to the left, and as B is perpendicular to the horizontal direction, it has no effect on the horizontal motion of the ball, so we can ignore B. Now, in terms of this direction, we have the force C pulling at 45 degrees to the horizontal. So in fact, the component of C acting in the horizontal direction will be C cosine of 45 degrees. The entire force does not act horizontally. You must resolve it to get C cosine 45 degrees. Now, as the ball is static and there's no net force, we must have that A equals to the C component in this direction, i.e. the force A is equal to C cosine 45 degrees. Now we know cosine of 45 degrees is 1 over root 2, so you must have that A equals root 2, yielding our answer to the first part, that C equals root 2A. Now let's resolve in the vertical direction. Now again, A will have no component in the vertical direction as it's perpendicular to it, but C will. Now this time it's not C cosine 45 degrees, it's C sine 45 degrees to get this component up here. And again, it must be equal to the vertical force of B, otherwise the object would accelerate. So we must have that B equals to C sine of 45 degrees, which we know is C over root 2, implying that C equals root 2B. Well, equating the 2 equations for C, we see clearly that root 2A equals root 2B, or simply A equals B. So we know the forces must be the same. Now this could have been intuitively quite obvious due to the symmetry of the problem. The force C acts at equal angles to A and B, and the object does not move, so it's clearly obvious that A and B must be of the same magnitude. And that's our relationship found between the forces on strings A and B, and the question completed.